Hi, welcome to video 9. In this video, we will learn understanding multithreading concepts in Java, creating threads by extending a thread class, writing a program to understand the need of join method, writing a Java program to understand sleep, understanding life cycle of a thread, writing a Java program to implement runnable interface, thread priorities, and naming thread, and introduction to thread synchronization, implementing thread synchronization. So let's take it further with our new discussion on Java. Now, Java, obviously, there are a lot of things which people from Java team have done is to ensure that they all connect real world problems. On the verge of it, one happened to be something like this. Understand this little carefully. I have a business logic. So let's understand. I'm not writing public static void main. I'm just trying to derive it as simple as possible. I'll have a method which is called as hi. So in my main, I have a method called as hi. I have a method called as hi. This guy eventually will try invoking hello. So hello is another business logic or another method. This invariably calls something called as CI. So CI is another business logic which does something. It does something. Imagine for whatever reason, for us today, you have like a lot of method. Now, this is just an example or a heads up I'm trying to give it. This could be any method in the world for us. So any complicated. I have a method one, calling two, three, four, and so on. That's the whole idea of having it. Now, imagine in order to execute them, maybe just imagine yourself there is something like a database which gets connected for these people and they do their own jobs, blah, blah, blah. I don't know what they're going to do with it. Imagine if there is a user who is called as CB who's going to come for invoking business logic. As an user, obviously everybody will consume CPU burst time. Now, CPU burst time is the amount of time required for any job to do it. And CPU burst times are always approximate times. They're not exact or real times. So keeping this in mind, so let's assume CB would take about 20 milliseconds. So for executing his job. Now I'll also have Ashwini. So when I have Ashwini who's gonna come, so she would take for executing this business logic, maybe complex or simple, how what data, whatever, it is 12 milliseconds. I will have Cami who's gonna come. So she will have about 25 milliseconds. Then I'll have Krishna who's gonna come. Now she needs around 10 milliseconds. I'll have Tripti, so who's gonna have around she needs around 9 milliseconds, right? These are amount of time to be required. But the problem here is not that I don't want to execute. The problem here is amount of time spent for all these people by the time Tripti gets a chance. So if Tripti has to get an opportunity for executing, then invariably she has to wait for 20 plus 12 is 32. 20 plus 25 is 45, 55, 65, 67 milliseconds. Around she has to wait for 67 milliseconds to get an opportunity for working it. Now this is unfair for somebody who want to execute for 9 milliseconds and you are consuming around 67 milliseconds. And what is the total time required for doing the job? For completing the job, we need 76 milliseconds. So if you just calculate little math, so the total amount of time required for completing the job is 76. So now the whole idea here is not to reduce this time, is not to reduce the time, but to give an equal opportunity for everybody to execute so that they will not be there in the system for a long time waiting and blocking other people. It's like this. If you just go to some shop and there's a long queue, for whatever reason, you have only simple one article, maybe you've just gone to somebody like Target or Walmart. The whole idea here is to buy a pen, and on a rough day, you are being made to wait for like 1 hour, or you get frustrated. So we understand that we are in a queue, but just to buy a pencil or a pen, you're made to wait for such a long time. That's really bad. So I have to have an opportunity where there is some kind of mechanism which addresses this problem, and it gives opportunity for everybody to come and talk and check how many articles you have it. If it is lesser than that, they should do a billing pretty quickly. That is where we will have some nice algorithm which is called as round robin algorithm. Now, the idea behind understanding this is to introduce a new topic in Java, which is called as threads. Threads. What is threads? You have to show what is called as parallelism in our application development. So, how do I show parallelism? In order to show what is called as parallelism, I should have an opportunity where more than one program or some task getting executed. In reality, if you look at my system, my here, there is nothing called as parallel execution in the world. So you say, hey, let me look at this. I have a notepad executing. There's MS Paint executed. There is a Excel sheet which is working. There is a Zoom software which we are running. Eclipse is there. Notepad plus plus Chrome. Now Explorer. There is nothing called as parallel execution in the world. The switch between each application happens so fast that human being feels that there are multiple processes executing. If not, there is nothing like that. So hope that was clear. The switch between multiple applications happens so fast that human beings will feel that there are multiple jobs are getting executed. But in reality, we don't have. But what happens in reality? How does this parallelism achieve? They all do it with the help of somebody called as threads. Just to give a simplest example for this amount of time, imagine if I have Sibi who's going to come and execute, so he will occupy around 20 milliseconds, perfectly fine, right? So then Ashwini would come, she'll occupy 12 milliseconds. That's perfectly fine. Then I'll have Cami, she comes and occupies around 25 milliseconds. Then I'll have 10 milliseconds. And finally, I'll have somebody who occupies around 9 milliseconds. The whole idea of execution here, it happens in this fashion, which is in towards right arrow. So you have to finish off 1, 2, 3, 4, 5, and so on. But now I don't believe in this model because there might be possibility CP might come, Ashwini might come, Kami might come and occupy like 200 milliseconds. Then Tripti or Krishna is made to wait for a really, really long time, which is unethical or neither a good practice. Rather, what we have to do is we have to use somebody here as round robin algorithm. What we do is here a computer or probably somebody like Java will have something called as quantum time, or we call it time slice. Time slice or quantum time, right? So for this to happen, every before JVM could take up any job, JVM will decide there is something called as quantum. Imagine the quantum time here is 9 milliseconds. Now you may have to understand very cautiously when CB says operating system or Java saying that, hey, look at this Java, I need 20 milliseconds for executing my job. Now what your operating system does, pretty much it gives you around 9 milliseconds for executing. So you will keep your 20 milliseconds as it is. That's the total time required. I will have 9 seconds which to be executed. So remaining amount of time you needed for execution is around 11 milliseconds. I hope this is making clear. So what happens? Out of 20 milliseconds, which was asked by CB, he will get an opportunity to execute 9 milliseconds. The rest 11 milliseconds, the operating system will do something called as context switch. Context switch is something switching from one application to other application or one thread to other thread. That's the whole idea. right? Then what happens? I'll have a next guy who's going to come, who is Ashwini. Ashwini needs around 12 milliseconds. Now again, Ashwini will get um, around 9 milliseconds for executing. So what Ashwini will do is, oh, you have given me 9 milliseconds, no problem. How much am I left out with? I'm left out with something like 1 millisecond. So I still have to make sure 1 millisecond is executed. The same thing will happen for everybody. In the next go, at the end of it, if you see here, Tripti will get an opportunity to work around. She's got a job for 9 milliseconds. So here she finishes everything by 9 milliseconds. Now, how much time Tripti have to wait for? Let us calculate. So we have like 1 CB, 2 Ashwini, 3 Kami, 4 Krishna. So we got like 4 people. So 4 nines is 36. So now Tripti has to wait for 36 milliseconds to get an opportunity for executing. If I did not follow round robin algorithm with the quantum time of some number, then invariably for reaching this 9 milliseconds of job for Tripti, I have to finish 67 milliseconds of time, which was really, really costly. Now, Tripti, if she is waiting for longer time, she may undergo a concept which is called as aging. Now, aging is something, the process, if it does not get an attention, they keep troubling it. It's just something like this. You just go to a grocery store and you want to buy a, you just have to buy one grocery and you're made to wait for like 1.5 hours. So, invariably, you undergo aging. Now, this is what even in technology we're going to do it. So, this can be tackled by somebody called as threats. So let us go back and try understanding this guy, how he can help ourselves to do or execute things faster. Sun Microsystem defines a thread as a single sequential flow of control within the program. Threads are a code sequence that executes within the process. It is sometimes referred to as execution context or lightweighted process. Thread-based multitasking environment allows a single program to perform two or more tasks simultaneously. The thread in Java is, in fact, the realization of OS level thread. So, what does this mean? Let's summarize this slide here. Imagine yourself, we have somebody on top of everybody, a Superman whose name is operating system. Operating system invariably have various applications. So, let's assume the application is something like MS Paint, which I just executes. That's a process. I'll have Win. I might have PowerPoint. I might have Java. Java is just one application for this guy. So now operating system eventually have to do a job switch between everybody out there. Everybody out there. So now imagine every process when it comes, they are different. So MS Paint has nothing to do with Windows Word. Windows Word has nothing to do with PowerPoint. PowerPoint has nothing to do with Java. So it means I would just say these are all heterogeneous processes in the world. The whole idea of operating system to work around is a good operating system will execute all the processes simultaneously without getting the system in the problem. That's the whole idea. But now, if you are switching, or imagine yourself, tomorrow today we have something called as Java, where we are trying to deal with millions of objects. Now, if millions of objects which come to operating system for processing, now imagine something like this, where you have millions of processes here. So then eventually your operating system has to have millions of threads, millions of threads. Now operating system burn out its memory just to do context switch and does not do anything in the world. So we don't want to get into this problem. The whole reason is operating system when it switches any application, it switches with the help of processes because each processes it assumes that they get into system for their own intention. But on the other hand, we have a realization of a concept which is called as a thread. So in thread, what happens? These are all probably a child of Java. So they are like child of Java. The whole idea of having thread here is to show the workflow of the program. So here I'll have a thread which is called as T1, T2, I'll have T3, I'll have T4, right? They're like various threads. Now, if you see, T1 is not a process, T2 is not a process, T3 is not a process, T4 is a process. These people are just a piece of business logic which is written. They're all like business logic. It's just a piece of code which we are trying to write it. Now, the good thing about this is they are line-weighted process, and one good thing is T1, T2, T3, they're all like similar people. They're all child of Java. They have to undergo some rules before the job is being started. Though these people consume some time in the world as a CPU burst time, but still they undergo some rule when it comes to Java. So what Java does is Java, whenever it gets an opportunity from operating system to work around, Java says that, hey, look at this, Mr. Operating System. Today I have like four threads or four children of mine I want to execute. The good thing here with T1 to T4 is all controllable not by operating system, it is controllable by a developer like me and you. So make sense? So when I say controlled by uh, a developer, imagine if I want to get this application for pause, I can say T1 dot wait. I want to send this for sleep. I don't want this guy to trouble me for some time. I can say a thread dot sleep for like 1 second. So which thread? Whichever thread which is currently executing. So all these things can be handled programmatically. If I want to stop a thread, I don't have to inform operating system, neither to Java. I just say T1 dot interrupt interrupt. So pretty much everything in the world is happening in programmatical touch rather than delegating the job to operating system for doing it. That is where the threads start shining its job. So here we will have the whole control of Java to be whole control of the threaded application with programs. So now let's go. Here in the client server based app systems, the server program creates a thread. So that's what I want to say that allows it to respond to multiple users at the same time. A lot of GUI applications or programs have a separate thread to gather user interface events from host operating system. So we can also do a little bit of work uh, here. Okay, when it comes to thread, imagine something like this. If you are executing here, now till here, it is business logic where Java comes into picture. There will be some time where we want to give some delegation for the database to do some job in the world where it has to store, where it has to get whatever. In meantime, what do you want to do it? Do you want to waste the memory? Wait for that guy? No. What I can do is I can create another thread where it can execute asynchronously so that I'm not waiting for one person to finish the job. Rather, we want to execute asynchronously. That is where we were trying to talk this story where everybody should get an opportunity for executing. If you do a partial work, just go for stack. We'll do a context switch. The rest of the code will get executed in the system. Right? So that is where we can have the statement. So you can do other things while if there are slow IO operations. There are a lot of applications where people are trying to write it with the help of animations. When I say animation, let me just take a very simplest example where we want to do this ping pong. No, I just want to do a ping pong. So on the verge of doing the ping pong, here is the story. So I just have a floor, I just have a ball. I want to take this ball and I just want to take a ball. Imagine if I'm doing this ping pong. If I do this ping pong, you see that the speed of the ping pong is actually controlled by me. So I can say that every time when you keep moving it, you move it with some milliseconds delay of like 2 or 3 milliseconds. But now question is, if I am moving here with a delay of 2 3 milliseconds every time, what is my 2 3 milliseconds doing it? In the meantime, I can use those times for some other operations. That is where the threads will come into picture. So when it comes to thread, there are various ways to do it. But anyways, we'll get started with writing some simple program. Then we'll go with little complicated program or taking some real-time cases. So here is the story. I'll go back to Eclipse. Let me close all. All right. So here I've created a class which is called as thread example 01. So let's have the main method. Now, first and foremost, couple of heads up when you want to understand threads. The main method is the thread. In your Java program, if you have a method and if that method happens to be the main, then that is a threaded application. So far, everything what we have done is a threaded application. So I don't know if you have come across with any of the exception here. I'll click on play. I'll say okay. Look at this. It says exception in thread main. So did we notice that every exception when we were trying to write it, it is thread main. Unfortunately, so many examples which we did, we were all dependent on single threaded model. But now we want to have multi-threaded model. So now what we do is we'll just go back. We'll go back to this guy and say that this guy is a threaded. The main method is a threaded application. So for this, there are some basic information which JVM will inject it. Let's see what it is. So current thread name, thread dot current thread dot get name. Let's see what is the thread name. I just click on play. Oh, it says current thread name is main. So that's a thread name which gets created every time. I can also get the priority thread dot current thread dot get priority. So here priority for every main is 5. There are some levels of priority. So here it gives the priority of 5, right? So now I will have some set of priorities. Here one is min. I just put one is min. Uh, 5 is norm, 10 is max. So these are ranges. I can have priority 1, 2, 3, 4, 5, 6 up to 10. By default, there are few constants which these people have created and kept it. If I want to create some application, I may need few threads to be executed. On the verge of it, let's try creating a simple application to understand this much better. I'll create a new program here, a class. Let's call this as thread example 01. Now this program, imagine yourself, there are few people. One is main, that's something which you have it. I want to have some business logic. I'll say class banking business logic. Now, banking business logic, we are just planning to do something, some business logic, which eventually try doing it. But now, if you see, I have a class and I have a different class. There are like two different classes. Likewise, I can have multiple classes. I can have banking class, insurance, business, logic, right? I can have as many classes as you. Now, the whole idea here of having these many classes is everybody has to depict what is called as parallelism. But just to keep it simple, I will delete this class. I leave this work to you to incorporate one more class little later. But as of now, let's have the banking class. Now, what happens? What happens here? What happens? This guy, who's the main, will obviously execute. So he has to execute. No, he will start putting some business logic. But the whole idea here is just not to execute the main. Rather, I want to have another thread or another job which will act parallelly. In order to achieve it, I should have some mechanism because we had to be very cautious to understand the main is the first guy in the world to come into picture. If there is no main, there is no work. The main has to be there in order to make something to work in the world. So this guy should have an opportunity somewhere we're gonna write here, which will create one more thread. So I can have one more thread, which is it's just a continuation of main. The main can keep executing. So look at the way when I try drawing it, you make sure there are some gaps here. Now you see that there is a gap here, which I'm trying to fill out. The whole idea here, this part is not used. This part is not used. This meaning when one thread executes, the other thread does not execute at all. The whole idea here is the switch between the processes or threads are so fast, human being feels that two operations are running it. And in reality, it is not. Likewise, I can also have another thread created. Okay, I can have another thread created. I can have another, this guy executes. I can have this guy executes. I can have parallelly another guy executing. So at the end of it, I can have multiple threads getting executed, and everybody undergoes an algorithm of round robin, what we have discussed it. On the verge of it, if I want to show that, I can use everything in one business logic, which or one method, which we don't want to do it today. Rather, we want to delegate few jobs to banking business logic or somebody like insurance business logic, or there is something like a loan business logic or whatever. There are like hundreds of people whom we can go ahead and think today, right? The idea here is how can I make this? In order to make it, there are few rules which we have to follow. Now, these rules, when I say follow it, they're all the rules defined by Sun Microsystem. Those we are not allowed to overwrite it. How it is, why it is, let's have a look at this. Every application, when you try writing it, I'll just put like threads, just a quick word. Yeah, perfectly fine. So when I say threads, if I have this class called business logic, the whole idea of having business logic behind the screen is to extend object. So that's what's going to happen. There's nothing fancy this guy can do it. But today, I don't want this to happen. I want something else to happen. So what it is, imagine yourself. We have a main guy who's the first point in contact for executing. What this guy eventually try doing is he starts executing it. But now I have to tell operating system or I have to tell Java because it is also possible for us to have multiple instances of Java in the world. As you have multiple threads, it is also possible to have Java in the world. Now, we may have to understand this something like this. You have Java, you have multiple threads. I'm trying to say this Java, this version of Java, which you try having it, I can have hundreds of Java instances in operating system. Each of that instance of Java can also have threads of its own. Now, keeping it short, to discuss our point, here we will take the discussion only with one Java instance because as of now, I'm trying to work only on one Java. Over a course of time, it is possible we can create multiple instances. Anyways, now, when I say one instance of Java, you have a thread which is called as T1. Let's consider this is the main. Now, when I have the main thread which is executing, I have to create another thread. How do I create another thread in Java? To make sure to have another thread, we have to write this class extends thread. What is there in the thread? Now, this thread class is a class which is written by Sun Microsystem those days to showcase some parallelism. What does people do on the parallelism here? There are few internal methods. There are like some fancy methods. Out of that, I want to show you one method where not with the business logic. If you want to see the business logic, again, we have to go back to the source file. provided the time, I can show you. There's a method here which is called as start. Start. Now they have written something. Let's not really understand what is there and all. That might be little time consuming, not of our job. What I do is in the main, I will say, hey, look at this. Today, in the main, I just have to say, I need business logic, BL is equal to new business logic. That's my class. I just have to say BL dot start. BL dot start. Now what this guy does is, the moment I say start, the start method is already there. And do remember, business logic as a class is not having start. Since business logic is extending a class called as thread, and a thread class has got a start method, it means the business logic also has a start method. Makes sense? If your parent has a start method, and if it is publicly visible, it is as good as you have it. So now, when you try having it, this guy will make a call to start. When he makes start, now what happens behind the screen is interesting. This guy, this guy will invoke Java and says need a new thread. That's the first thing. Plus intimate OS to create a native, very important native thread. We remember our first day's discussion where we used to have a program context between C, C++, and Java. When I say C, C++, these programs are called as native program, meaning when I have a C program written on Windows, it meaning it works only on Windows. That's perfectly fine. But on the other end, if I have a Java program, I can pretty much try taking it to any operating system. In fact, this is partially true. That is only partially true. The other half is something like this. When you want to create a thread in operating system, now Java have to talk to operating system in its own language. Operating system will never talk to Java in Java language. That's not possible. It's something like this. Microsoft Windows will never come to Java and say that, oh, Java, you're becoming great day by day. Let me understand your language. That does not happen. No, practically not possible because as a Microsoft operating system, they have like thousands of applications which they can run on. Rather, it is the application's responsibility to understand the operating system and try talking to this. That's where this diagram comes into picture. I have Java. Java has to talk to operating system. Now the question is, what is your operating system? Even I don't know. As a developer like me and you, let us not understand on what operating system we are working on. We are only concentrated on I need a thread on respective operating system. Behind the screen, what these people from Sun Microsystem do is they will invoke Java and says they need a new thread and intimate operating system and create a new thread. So how these threads are created here? These threads are created here. These threads which you see it in this bucket in this place are intimated to operating system. The operating system will help me to create one thread so that that could be a place where I can execute some job. Likewise, if I want multiple threads, what I do is I'll go back to this guy. I will try creating business logic BL2 is equal to new business logic BL2 dot start. So what again happens is I will have a thread. So you understand this at this time, the moment you say start here, there will be a thread which gets started. It means you already have a thread here. You already have a thread here. When you say start here, there's another thread which gets created. Likewise, I can have any number of business logic or any number of times I can have this start done on different objects. Invariably, what happens? New objects getting created. So this guy will create something. He do some magic. Once he does it magic, he will invoke another method in the thread class, and this method is called run method. Run method. Do remember Run is a method which should not be invoked directly. Rather, run method will be invoked once the thread is created successfully by Java. When you invoke start. So do remember when I say start, it does some magic here and gives a control to run, and all business logic for us, logic goes here. So hope this is making sense. All our business logic will go here. So I think I have a slide which depicts that. Look at this. Here class simple thread extends thread class. Public void run, that's what we're going to do it. So here, when I say start, calls run method. Internally, there are some job which JVM will invoke operating system to get it done. I don't know if I could really show you. Yeah, here it is. It's little vague, but a lot of things would happen. If I say c.start, a simple thread, this will go to the class which is called a thread class. Thread class has got start. The start does something which makes the operating system level call and calls a method called as run. And run does something and gives a control back to your class, which is an overridden method. Now I can have any business logic to be kept here. We will ensure this class extends thread class. This is one way of implementing thread class. So here we have to override a method. You make sure that you're always overriding only one method, which is called as run. You can also see there is start. This start method in your project, if you are working, 99.9% of the people in the world will not touch until you come from the core development of Java. If not, you will not do it. In fact, this code, till today, I have not seen it. I'm sure that if you are really excited to see how things happen, you may have to again go back here in JDK, because JDK is the openware software. Here you will find everything what is needed. So you can keep everything, which is like Java, lang. I should find lang. There's somebody called as thread. So there is somebody called as thread here. Yeah, thread class. So I can have this view. So this is where I can have start. Uh, start. P dot start. There is a method. Yeah, public voids. Look at this. They do their own jobs. This method is not invoked for the main method or the system. They're basically methods which will help you to create the operating system level threads. And very importantly, do you also see something called as private native void? Now, native is another keyword which most times people don't use it today until unless you have written some business logic in C and C++, and if you want to invoke it, only then you will use native. If not, they're gonna call the native operating system call. This is where I was trying to say. When you say Windows, they create a thread in Windows. If you say Linux, it will be in Linux. If it is Macintosh, it will be Macintosh, and so on. Right? So of course, this is not too much interested for us. I'm gonna go back and close it. Right? So here, I want to write some business starting. Now, this is not like very fancy. I just want to kill some time so that we want to show how things work. So I'll use a for loop of killing it for like about 500 times or 1000 times, whatever, I plus plus. All right. So here I would say something like this: system dot out dot println I value in I value is I in the thread. The thread is thread dot threl dot current thread dot get name. So that's the whole idea of saying it. So we just want to get some basic information of this, and let's put it this way. So I would say I value is 0 for the first time in whatever thread, because since it is static method, current thread is static method, and we also know that static is at class level. Any class which is accessing this business logic at that point in time, that name is given for us. And finally, I'll just put some message. I'll say exiting thread. The thread name which is exiting now is thread dot get current. I'm sorry, current thread dot get name. So what I do is just to keep a track on ourselves. I'll make sure that when the thread is exiting, I'll just put a message, right? So now I will also have some business logic here, very similar to this, very similar to this. Before that, here, I'll copy this. Here it is. So I don't have to say what is main because I know here it should say main and here it should tell me whatever the thread name which we gonna create. So what is the class all about? The class is called as banking business logic. Imagine that this is just a simulation. This is your simulating for a TP connection. Let's assume it's for a TP connection. Banking business logic BPL is equal to new banking business logic BPL dot start. But in addition, in between, you can have set name, the thread name. I'll say I want to have the thread name of um, somebody called as Michael, right? Uh, Eventually, we can go ahead and try creating multiple one, right? I also just want to put one more information, thread name with priority thread dot current thread dot get priority. So you can get the priority. You're getting the name and you also get the priority. So here you have the name, and of course, what we do is nicely copy this and put it here. So we're just copying it and putting it. And finally, we are exiting main, main. Perfectly fine. So now the output of these programs are never expected. It depends on various factors. The system load, the kind of operating system we are running it, and the processor, how it switches the job, the operating system amount of time given for Java for a quantum time, and how Java schedules each thread. There are so many factors which is needed to make sure this program will work. So let's go ahead, click on play and check. Great, it has did some job. Let's scroll back. It's a huge output to know what imagine know this. Now what happened? I value is 0 in thread main, so perfectly fine with the priority as 5. Then what happened? There was a context switch would have possibly happened. The thread called Michael has come and it has executed 3 times. Then what happened? Main would have tripled Java or Java has done the context switch from Michael's thread to main and main has got an opportunity from the place where it has left. From there, it has started executing for about 19 times. Then the Java has did a context switch to a thread called Michael. From there, 3 times it has executed. The fourth time, it has gone ahead and executed in a continuous stack for really long number of time. Then intermediate main has come. The main would have executed 1 time, and by the time it executes again, Michael thread would have come and undergone aging, or it has invoked or poked it, whatever, and this thread has got executed. Now look at this. This context switch keeps happening. Context switch keeps happening. So Michael thread would have executed, then main came, the Michael thread came, main came, all this thing. They just do jumble up. And again, you execute for like couple of times. The output here is never predictable the way how it works. The next time I execute, this will be a different output. Eventually, this is a different output. Look at this. Oh, main has executed 5 times. Then Michael got an opportunity. So he has executed so many times. Makes sense? Now, thread, the whole idea of having thread is to make sure people will get an opportunity, and all opportunity when they get is in the form of asynchronous way. Likewise, let us create another thread. Let us create another banking. business logic BBL1 or BBL2 is equal to new object. So I just want to say BBL2 dot set name. I just want to call another name. Let's call this as Ashwini, right? So here BBL dot start BBL2 dot start. I'm sorry. So what happened? This invokes start will invoke OS level uh, invoke. I'm sorry. Java invokes OS to create a thread and gives control to run method in the class. Right? Makes sense. So now let's go back and click on play. All right. So look at this. Ashwini's thread is finishing. Last I have main. So somewhere here, the like context switch which is happening. Now, if you see that there's a nice context switch which can happen. And probably since my stack is very less, maybe I'm not seeing everything on the go. Maybe 3,000 lines. It's too much for console to capture it. Maybe yes, we can still see the output pretty nice. So there's a context switch which happened with main and so on, right? So now the whole idea here, if you want to have threaded application, when people try writing um, parallel processing, they put their business logic here. They put their business logic in the run method. Thread example two, where we have some bit of business logic where we had two threads. One is called as Michael, one is called as Ashwini, which they did some job because they just want to hit to the server, killing some time. And we also had the loop repeated 1000 times in the main. Plus, we also had this guy who is run method. So run method will be one method in all our cases. Anytime we are trying to work around with the threads, make sure that the method called run is always overridden. That is where the business logic can be written in our case. All right. So now there's a little more thing. Let me just go back and play it. Let's go back. So now it says the last executable statement. So do you see that the last executable statement happens to be exiting thread Ashwini? Let's see what was your last statement which was supposed to happen. Do understand here very cautiously. You tried creating a thread which is called as banking business logic, which is basically an object running with a name called Michael, and there's another object with a name running which is called Ashwini. So my diagram will look something like this. The diagram will look something like this. So here we have somebody who is called as main, who's called main. So that's where we started. This is where the main is. So in main, I'll have a thread which is called as Michael. We set the name, we say start. Imagine yourself, the main is starting, and the thread called Michael comes. The Michael thread is something like this. It starts working. We say start. The operating system level thread is created. Once it gets created, you give a call to something called as a run method. The run method does some job for Michael. But you're not quite. Rather, what you do is you also go ahead and start invoking one more thread, which is by the name called as Ashwini. So now, once this thread is done, this guy who's called main will get an opportunity to execute. Once on the verge of executing, it says there's another thread which is called as Ashwini, which you want to execute. So that's where Ashwini thread gets executed. Now, eventually, you will have something like three threads which are parallel executing. Now, but the whole idea here is if you see the center thread is a guy who is a parent of these two threads. This thread happens to be the parent of these two threads. Now, do remember, in a well-behaved system, either it is operating system, either it is Java, .NET, Python, PHP, C++, anybody for that matter, the parent thread should be the one who should exit at the last. That's the whole idea. Now, why your parent thread has to work or should exit at the last? Let's consider. Every thread in the world will have something called as a thread ID. So this guy will always have a thread ID. Now, every thread will also have thread parent ID. Imagine, and of course the name. So let's put the name. I'm trying to give some logical names here, may not be real names. So I have a name, and this name was called as JVM. Now, JVM is a thread whose number always starts with zero. And who is a parent of JVM? Nobody. Nobody is a parent of JVM. He's like Superman in the world. There's another guy who is called as a main. Now, main is a thread which generally has a number called as 1, and the parent of that is 0. So you have to understand there's a main thread, there's a thread ID, there's a thread parent ID, which happens to be this. So I have to draw a line here. So let's assume I have a thread which is called as Michael. 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 Now I have the thread ID called as 0. For the thread called as 2, there cannot be a parent of 0, there can be only one thread. Because there's a rule saying that JVM cannot be parent of anybody except main. So the only left out option for instantiating a thread is the parent ID as 1. If I have something called as Ashwini, the thread ID, assuming it is 3. Now there is an opportunity for Ashwini thread to be the parent as Michael, or the parent can be made. Anybody from this category, either 1 or 2. So in such case, let's say something called as 2. If you look at this, every time I have the parent to be assigned before the thread starts the job. By this, what happens if there is a thread which is called Ashwini, which is thread ID 3, which is not well behaved in the system, then the parent thread who is called as 2, which has helped the thread 3 to create, can always come and issue something called as a stop, or something called as an interrupt, or it can take you to sleep, or whatever. So it can have a call because it's like a parent. The moment the thread starts, it is a duty of the thread to report to the parent. That's very important. But what happens? Imagine if I have a thread which is called as Ashwini, I have a thread which is called as Michael, I have a thread which is called as Tripti, and so on. So many threads are there. And for all the threads, imagine if the main thread is the parent, and if this guy finishes, it means Michael does not have a parent. So this thread becomes anonymous and it just starts again. Since this guy is not having parent, it has a loose control on the children's of it. Now that is where the problem arises in threaded applications. To avoid it, we always ensure this thread, which is called as main thread, which is a main thread, should be the last thread to finish it. Now, how do we ensure it? Imagine yourself probably in our school days. Now, I'm sure that we have all enjoyed school days. So we've gone to trip and we have somebody like physical instructor who is one point of contact where all the kids has to go out and come in. Once everybody is in, he will make a count, and once these people are all in, so we can depart from the place. That's the whole idea. If one person is not departed, it is his responsibility to make sure find that person, he or she. So how do we achieve this? In Java, we achieve it with somebody called as join. So we have an exclusive method here, which is called as join. Let's see how does it work. So according to our discussion, main is the first thread and it has got two more threads. And we have some job from main. So main is also part of the container. So this guy also kills on the job. The previous execution, what happened? Somewhere in the story, this is my output. So here I should find something called as main. Let's see if I could figure it out. So here, exiting, I'll say, I'm sorry, exiting thread main. Okay. So what was that? Okay, 1 second. So exiting main thread. I'm sorry. I just have to copy this and paste it here. Control F and paste it. Okay. So do you see that exiting main thread has come? After this, there are couple of threads or couple of executions from Ashwini happening, maybe even from the Michael, whoever. But the whole idea here is this guy who's called as the main happens to be the parent for all the threads which gets created. But I want this main thread to execute or exit at the last to make sure that it will leave the system with no troubles. So here, what we do is we'll try incorporating a new state. I have a thread which is called as BB1 dot dot join join. So look at this. The join is in the method comes in three versions. The first version, which is join, which does not take any parameter. That's where you have it. The next guy is join who takes long. The next guy is join who takes long milliseconds and int nanoseconds. The whole idea here is the first one, if you are trying to use it, this will be indefinite wait. It means if the Michael job or Ashwini job takes more time and they don't finish on time, the join will eventually wait for them to finish it. On the other end, who's got milliseconds, I will say I will wait for like few milliseconds. I'll wait for 1,000 milliseconds. And if you don't join me within 1,000 milliseconds, I'm gonna go out. The next guy, since the processor speeds have gone really high these days, so this will wait for milliseconds and nanoseconds. For example, I want to wait for like 10 nanoseconds. In such case, I can pass it like 0, comma 10. That's a whole idea. But in my case, what I do is I can select somebody called as join, which is indefinite join here, here. So here, there's another guy who's called VVL2 dot join. So these are two threads I'm expecting to finish the job before this statement, which is called as exiting main, can come into the world. So since these methods might throw an exception, and the kind of exception which is called as interrupted exception. Let me just hover it, or I can just select it, right click, surround with, try catch. You can go ahead and type it, or you can just use the ID's help. So that's where you have it. By doing this, what happens? Eventually, the main method will be the last to execute. The join will make sure the threads with the named are finished first. Only then the control is given back to the rest of the statements here, right? This is very, very handy. If not, the system will start behaving abruptly. That is one of the problems which we have it in any of the operating system or Java. Right from the Windows to Unix to Sun Solaris, whatever you try taking it, everybody have to behave in the same fashion. And no thread or no parent thread in the world has to exit before the child thread finishes. That's very important. So keeping that in mind, let's go back and click on play. All right, look at this exiting main thread. I'll execute again. Oh, main thread is executed last. Main thread executes at the last. So every time, whenever you're executing, the main thread should be the last to execute in the world, which is called as a main, which is executing. Now what happens? Eventually, there's another thread which comes into the world. Let's assume this is a Michael thread, which is executing. Now what your main thread will do? Main thread will eventually start executing parallelly. So here. So do remember there's a gap here. There's a gap here. Now the gap here, I assume that we are all running in single processor system, not like multi-processor systems. After this, there might be an opportunity where I can have another thread which is executing, which is called as the Ashwini thread. So again, we'll go back. There will be a race condition between that, and so on. So these people will start executing parallel. Now, as a thread, which is called as the thread from Michael, or a thread from Ashwini, or the main thread, anybody for that matter in the world, should be well behaved in the system. Now, when I say well behaved in the system, meaning these threads, when they come into the execution, they should be called as cooperative threads, so that they give an opportunity for other threads to execute for a little bit of time. And these threads should not be a cunning threads. So the moment these become cunning threads, it means they occupy so much space and memory in the system that will be the very high chances that system may get into the trouble. As a developer, it is our responsibility to make sure that the thread does a job and there is a small lag so that the utility operations are taken care. Now, when I say something called as utility operations, imagine yourself that you have come to a website, somebody called as citibank.com, city.com. So once you do some job, for example, transfer of a money or checking the balance, paying your EMI, whatever. So in such cases, once the job is done, I have to have a small lag so that if there are some utility threads which has to act upon the running thread, they have an opportunity. If you are not giving a lag, then immediately the next thread will come into picture. That might execute perfectly fine, but the utility things which you wanted to do it on the thread one will not be suffice. To make sure that every thread has to give something called as delay. For example, here I'm just trying to show this may be a conceptual example. Here I'll say thread dot sleep, thread dot sleep. So I will say, hey, once after my job is done for one time, I want to give a delay for like 50 milliseconds. Perfectly fine. And this guy will give you a interrupted exception. Again, I'll go back and put it in try catch block. Now for this, there's another diagram which we may have to look at for easier understanding. Every time, every job, when you get it in the system, there's no guarantee that they will execute completely. Now, when I mean, you have to refer back to one of the diagram which we tried using it here, which is with round robin algorithm. We remember this diagram where you don't have an opportunity for executing complete uh, uh, job. For example, CB has got 20 milliseconds, Ashwini has got 12 milliseconds, Cami has got 25 milliseconds, and so on. Now, nobody here will get an opportunity to complete the job fully. Rather, they have to be split in bits and pieces so that they get an opportunity for doing it. So, how do I get that opportunity for doing it? We make sure that we put it as a thread dot sleep. So, when I put thread dot sleep, it means the current thread which is executing will go for sleep for 50 milliseconds. In meantime, as a Java, the JVM is very intelligent. What this guy does is he will go and check is there any other threads which is in the queue and it will start executing it. That's the whole idea of having the thread.sleep. I pretty much copy the same code here. I'll copy it and put it here as well, just as a reference, right? So I just put it as a reference so that we'll have a equal lag in each of the execution. So let me click on play. I'll just stop it for a minute so that we can see the console nicely. So here, have a look at this. The main thread executed, Michael thread came into the world. Michael thread went on to sleep for 50 milliseconds. In meantime, what JVM did, it did not keep quiet. Rather, it gave an opportunity for executing Ashwini's thread. What Ashwini thread did is she came, executed for whatever time she wanted, then went for sleep. So then Michael had an opportunity for executing. Now Ashwini has an opportunity for everything. Then main came into picture. So there will be a clear context switch between these people so that everybody are respecting in the ecosystem so that fairly everybody gets a job. Even in our most of our applications, we make sure that there will be an opportunity for other threads to be executed. It's not like only one thread has to execute. If one thread has to execute, then those threads are called as selfish threads. The moment it is a selfish thread, in such cases, this diagram has to uh, come in picture. So what happens? Imagine if there is a thread which is called as 3, which is executing continuously, which is not giving opportunity for any other threads to execute. In such case, this will be informed to thread 2. This thread which is informed to thread because 2 is a parent of it. Then there is an opportunity that the thread 3 can be killed by thread 2. That is where the ecosystem is built in the world, or that's how it is built. So let's have a look at one more diagram. One more diagram. So here, imagine now the entire system, how it works in our ecosystem. There is one of a thread diagram, very widely used. Imagine yourself, there is a new thread which is born. So when I say new thread which is one, I would put it as a state which is called as new. Now what happens? There is a state here which is called as the run state. Now run state is something which is your running state, so that the thread is actually executing. It means it is killing some time, memory in your operating system, or hardware is getting burnt. Any thread which comes to world as a new will never get an opportunity to execute. This is not possible. This is not possible at all. Rather, every thread, when it has to come, it goes to a special place which is called as runnable state. Runnable state. A runnable state, in the simplest term, you can call this the queue. Queue. So what happens when you say new that will go to runnable state? When does it go to runnable state? When you issue a method which is called as start. So when you say start, the OS level thread is created and this is kept in the runnable state. So when we say start, do remember very, 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 very cautiously when we say start, there is no way the thread will directly go for execution. Again, I repeated, the amount of time taken by processors are so slow that human being feels that parallel processes are executing. That is in a similar way, if I issue a run, we feel that it is immediately getting executed. In reality, that does not. Rather, the job is kept in the runnable state. The runnable state once it keeps it. Now, from here to here, we as a developer have no control. This is done by somebody called as scheduler. Now, what kind of scheduler? They use some scheduler like RR, which is Rabbit, and PFS. PFS meaning priority first scheduler. So based on these two schedulers, what they do is they get it to the run state. Run state is the time or amount of time where the thread needs to execute. Once completed, what happens? The thread has to go to some state, which is called as a dead state. Let me use something called as dead state. Now, when does this occur? By stop. There will be a state here, which is called a stop state, or we call it interrupted stage. Interrupted stage. So now imagine yourself where you have a business logic of about 55 milliseconds to execute. The whole question here is 55 seconds executed in one go. No, this does not happen. Rather, 55 seconds is broken down into bits and pieces. Into bits and pieces. Maybe like the context time or context switch time is around 9 milliseconds, 4 milliseconds, 2 milliseconds, what. So let's assume hypothetically we will not have an opportunity to execute 55 milliseconds in one. Now, what happens if I have this job out of 55 milliseconds, which is getting executed for about 10 milliseconds? So we execute for about 10 milliseconds. So rest of 45 milliseconds is that. Now, how does this happen? Imagine yourself every time there is an internal context switch, which system will do it by itself. This control is with JVM. There are certain opportunities, there are certain needs in the world where we have to do our own switching algorithm. In such cases, we have few options here. Now, first and foremost, if you are executing in the run stage, you can get this thread and put it in a stage with uh, something called as sleep. Or let's do this in the context switch state by the help of which is called as sleep. You can get the process into context switch state by any method, which is called as sleep. Once you issue a sleep on the executing thread, then that thread has to wake up by itself. This guy has to wake up by itself. Why? Because when we did sleep, if you could remember here, here we have very clearly specified thread dot sleep of 50 milliseconds. It means after 50 milliseconds, it has to wake up and start doing a job. So you are not allowed to invoke it no separately. That's the first thing which we have to understand. So you give a sleep, that wakes up after a delay of time. There's another guy here. Now, once if the thread is executing it, so there could be a possibility the thread I want to put it on wait. When does it wait? For example, imagine there's a common problem in the world which is called as um, consumer producer problem or producer consumer problem. So the whole idea of having producer and consumer is the producer keeps producing messages, the consumer keeps consuming messages. One of the classic example of this is Java messaging system. So what happens if you assume yourself there are two systems, system A and system B. System A keeps producing the messages, system B has to consume it. So I cannot go ahead and keep consuming or keep producing it just like this. Rather, there should be an opportunity where producer comes into picture, keeps producing for some amount of values. Then the consumer has to come and consume it. Only then that will be a pretty good system. In such cases, if the consumer is, if the producer is reading so many messages, I have to again get this guy in the context switch mode, which we do it with something called as wait. Wait. The wait is a call, as we have joined, wait is a call, which will help you to get the thread into context switch. Once the thread gets into the wait, if it has to come to a runnable state, you have to issue a method which is called as uh, wait notify. Notify. So what happens if the thread goes for sleep? That thread has to come back to the system again with a call which is called as notify. Once it comes back to the system, and do remember this will always go back to queue. Queue. There's another guy where it is possibly possible for us to have it, and this happens to be when you're executing, there's an opportunity where you can send it to context switch with something called as suspend. In your projects, you will never get an opportunity to see what is called a suspend. Suspend is like when two threads or the thread which is misbehaved in the system. At some point of time, the parent thread has to issue or a developer can issue suspend. The moment I say suspend, the thread is immediately stopped whatsoever. Then, if this thread has to come back to the system in the world, it has to issue by something called as resume. Resume. A quick heads up on this diagram. If I issue the sleep method, then I cannot notify because sleep has to wake up by itself. If I issue suspend, it will not work by itself. It will not wake up. For this, I have to mandatorily issue thread dot resume. I cannot do notify. So do remember, if it is sleep, it has to wake up by itself. Wait, it should be notify. If it is suspend, it should be resume. So that is how the system is designed in our case. Imagine yourself if you have a class which is called as business logic, which extends thread. Now, perfectly fine. We try to public void run, blah blah blah. All those things are good. Imagine if I have a class which is called as something like night lamp. You remember our discussion on the interfaces where you had a lamp and night lamp, extends lamp. And how can I make this class threadable now? This is pretty challenging. For this, these people from Java community have introduced the same behavior of the threads with an interface which is called as runnable. I can have implements runnable. So when I say runnable, what happens? You can have your class extending any class. We are perfectly fine. Plus, we can also have an interface which is acting upon it. And runnable as an interface, this is what probably people from Sun Microsystem have written it. They have written public void run. So since this method is abstract method here, then If you have a class which is implementing runnable interface, then it is mandatory that you have to override this method. You have to override this method. Of course, we have seen this a couple of times. Overriding is important or mandatory when the abstract class or the interface has a method, because interfaces are all 100%. So you can have your class extending a thread class, or we can have our class extending any class but implementing runnable interface. But there's just other way to show it. Let us put this in the practice and understand it better. So here, I'll just go back and close this files thread. I will have to copy this and paste it here. Yeah, here is the place. So thread 2, and I'll also create a new class. The class is called as thread 3, thread example 03. So here, this program to show working of threads using runnable interface. So hope this makes sense. So as usual, we'll have your main as clean as possible. On the other way, so what we want to do is we want to introduce a class which is called as lab. Imagine yourself. So this will have some business logic, you know, some business logic. I don't know what you will write it, but I just want to end it. So that's the simplest class. But I also want to have a class which is called as night lamp, which extends lamp. But I want the threaded behavior for it. In order to achieve it, I use implements implements. So here, since it is implementing runnable, let's hover it. It's an interface. Add unimplemented methods. The unimplemented method happen to be run. Perfectly fine. Now, do remember something like this. Here, night lamp NL1 is equal to new night lamp. Right? Can I say NL1 dot start? Look at this. I will not be able to do a start. So here, the moment I put yes, I don't have the opportunity of saying start at all. But on the other end, when you see this thread example two, I'll just go back and say, hey, I want to have banking business logic PL3 or BBL3 is equal to new banking business logic BBL 3 dot. The moment you say start, it is showing up. It means that comes. Now, why is this happening? So when we have BBL, the start method is visible. But when I go back to this guy who is thread example 3, he's still implementing Runnable. Here when I say start, you don't see it anywhere. Yes, anything, there's nothing called a start. Let's understand this a little better. I'll go back to the paint. There are two ways of executing. I'll just go back and delete it. Anyways, we have saved. So here, there are two big ways of executing it. Now, first and foremost, with extension. So what happens? There's a class which is called as thread. So somebody have written this class. Who's that? People from Sun Microsystem have come and started writing it. The whole idea here is they have written a method which is called as public void run. There's some implementation. Don't worry what is that. Public void start, public void interrupt. Likewise, there are so many methods which these people have written. So now what happens? If I have a class which is called as my business logic, which I've got something called as my business logic, which extends this class, which happens to be thread. If I have a method, if I don't even have any method, if I don't even have any method, now I can say my BL B1 is equal to new my BL. It's perfectly fine. Now I can say BL dot start, and we know from our discussion if the superclass has it, the subclass will also have, provided they'll have a public behavior, right? But on the other end, you have a class. On the other end, you have an interface this time, interface, which is called as runnable. What is there in the runnable? The runnable has a public void run as a method. So if I have a class which is called as my business logic implements runnable, in such case, we will not see anything called as start. There's only opportunity what you can have is you can override a method called as run. Apart from that, nothing can work here for you, right? That's the big challenge. But still, I want this to be made as part of thread. How do we make it is something which we're gonna explore it. So first and foremost, to give heads up, when you say start, that doesn't work because they don't inherit anything from the thread. Now, when I say runnable interface, they only behave because we know that the run method is the only method which you should have it to make sure the control is given. So in order to do that, I try creating few objects. Now, first and foremost, I create an instance object thread, 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 thread. I'll also have string name. I can also have int priority. So as a good programming practice, we'll make this as encapsulated private. I'll copy this, paste it, copy this and paste it. So here, public night lamp. So whenever I create a thread, what I do is I'll take string name int priority. Let's say this dot name is equal to name, this dot priority is equal to priority. Now what happens when you try sending a name, I want to create a thread by that name. So look at this. This is an object of a class called a thread. So I'll say thread is equal to new thread of this. Which class? We just say it as this. Or you don't have to pass any parameter. It's always good you pass it as a parameter which is called this. This meaning I want a thread of this class. That's the whole idea of having this. I'll say thread dot set name is name, set priority is priority. Since we have already set the thread priority in name, I would still keep this on a hold. So the whole idea here is you try having a constructor, the constructor creates a thread and sets the name, sets the priority. Once after this, the thread as in the class has got a start method. Once the start method, once you call start method, then the OS level thread is created, then the control is given to run method. The control is given to run method. Hope this makes sense. In meantime, there is a run method which is waiting here, where we can put any business logic. So whenever we say start, what happens? The OS level thread is created, then the control is given to run, and we know that this class is implementing an interface which is called as runnable. Since it is implementing an interface called as runnable, overriding the method called run is mandatory, and we have it, and the control is given here. So now what we do is we just copy a little bit of code which we have already done it. We just copy this. So not everything from the scratch. So here, so I value. Okay, so this one, I think we would have copied this for loop as well. This would be a very good idea. Okay, so here. So once after this, I'll say system.out.println, the thread, So I just put a message. That's the last message which I want to show it to the user, just before exiting. So this keeps going on. So here we try creating a night lamp. Let's see what is happening in night lamp. This seems to be perfectly fine. So I create an object of night lamp, and it needs an argument. We know what are the arguments. The first is string. I want to create a thread which is called as Tripti, and I want to give a priority of 5. So here I want to have another night lamp for a couple of more people. So I'll say NL2, NL3, and so 3 is fair enough. Here I'll have Ravi. Great. So here I would just put a 4, so I'll just say 6. Perfect. Now you cannot issue a start here. Since you cannot issue a start here, you pass the parameter, it goes here, two parameters are sent, set for instance variable, set for local for the local thread, then issue a start. The start will invoke the run. So let's see if things go well. I'll say play. Have a look at this. It works absolutely fine. I have Ravi with priority as 4. So there is another thread. There are a lot of threads. Ashwini thread is there with priority 6. There is a Tripti thread which is priority of 5, and so on. That is where the beauty of threads will start shining with the runnable interface. That's what you have. The whole idea here, when it comes to thread, is something here. I want to execute a thread where the thread creates a child thread, that thread creates a child thread, and they keep executing parallelly. That's the whole idea which you want to have. So they keep executing like this. So you can also have more threads which are working. This is perfectly fine. So eventually you have so many threads which just get executed. Now here, when these threads are executing, they all execute in asynchronous. When I say asynchronous, they all get into race condition. So when I say race condition, they just come for doing their job and they are not too much keen enough for giving an opportunity for other threads to execute. But there are some problems in the world where it has to be addressed. The threads will be well behaved and they have to give an opportunity for other threads to execute. Failing which, failing which, your threads will is of waste. Let me take a simplest example. Imagine if you are an end user, if you are an end user who goes to buy something on Amazon, right? On a shopping site, shopping site. Now, what happens when we put everything and put it in a cart, right? We just put it in a cart. Once we put it in a cart, we have to do a payment. So when I do a payment, Amazon does not collect money. Rather, imagining that I am doing a payment via net banking. So what they do is they reroute to our, let's assume one of the bank where they reroute is City. Any I'm sure that we would have encountered this when you make the payment on net banking using Citi or any bank for that matter. So these people will put a message to the end user saying that on the screen, which looks something like this. Do not refresh the page for some time. Please wait processing your payment. Some kind of message like this. I'm sure that you would have seen this kind of messages, right? On the verge of it, there is another concept in threads which is called as synchronization. You have asynchronization. On the other hand, we have synchronization. What is synchronization? It is exactly opposite of synchronization. Now every thread comes in the world for executing its own job without caring who the other thread is, whereas synchronization is somebody who says, I will give an opportunity for you to execute till you finish, I'll wait for it. Now that is something called as a synchronization. I have a very, very, very classy problem in the world, which most of our banks in the world have eventually have put it. Whatever bank, wherever, it's a small bank from cooperative societies to the biggest application in the world, they have to have very similar to this. Let's have a look at this and understand this better. So I have a slide here which is called as threads. Let's go back. Imagine yourself where you have a requirement. You have a thread A which calls uh, to withdraw 500 rupees, and I have a thread B which calls to withdraw 750 rupees. Imagine the account balance before you start the transaction is around 1000 rupees. So when 500 rupees debiting information comes to account, that is perfectly fine. So you already have what do you call it, 1000 rupees as a balance. So you want to debit 500. So you have a sufficient balance. You should be able to do the job. What happens before the job gets executed? The second thread will also come. The second thread will also come. So this thread comes and says, "Hey, I want to withdraw 750." And this guy says, "Okay, do I have 750 at this point in time?" Yes. You have to be very creative in terms of understanding that these two threads, the same, different people with the different threads has come to same account and withdraw. By the time the transaction is finished, 1000 minus 500, the first iteration would have executed. 1000 minus 750, again it will get executed because this account itself will not, the account detail itself is not stored in Java. Rather, they're all kept in the database. So if you want to go to database, hit to the database, get the job done, and give an acknowledgement to Java, that will obviously kill some time. In meantime, if there is another thread coming out, Java will just blindly take it. And we know that the programming interfaces, somebody like cache memory, primary memory are much, much, much faster than secondary memory. So keeping that in mind, we will try introducing its concept, which is called as synchronization. I'll try having a class which is called as account. Let me copy this. I'll copy this. Here, let me show you. I'll collapse this. I'll close all the files. Here. This guy, I just paste. That's an account file. So account file has a little more extension. Let me just copy that part as well. I just copy this and say yes. So here, I just put it. Control Shift P. All right. Here, requested available. Blah, blah. I think there's no more error. There's no more error. Control Shift P. And so on. So a very simplest example here. Imagine there is a class which is called as account. The class called as account has got a private variable called as money. There is somebody called as account amount. So what we do is initially I will instantiate amount with 1000, but we may have to assume that we are hitting it to database and getting it. That's where the data is kept in the constructor. So somebody in the world who comes and says, "Hey, look at this, I want to withdraw the amount." I may have to check if the required amount, if the required amount is less than money, which is balance in your case. If it is, if the required amount is like, if the balance is like 1000, imagine, and the required amount is 500, you will do a check. Is 500 less than 1000? Yes. So here I put thread.sleep. Now this guy, meaning simulating to hit to DB, right? And balance from the system. So obviously, let's assume that he will take like about 1000 milliseconds. But once after taking 1000 milliseconds, the balance is equal to balance minus amount, which is requested for. And finally, we give an acknowledgement saying that, "Hey, look at this, we have received an amount by whatever thread name. Now, whatever, we'll just give some logical name, thread name. Else, we'll say, sorry, the thread current thread get name requested amount is not available, and the balance is so and so. Okay? So I just put it in next line, which is not available and so and so. There's a simple implementation class, no complication, but I just want to use an Runnable interface. Let me copy this. I just copy this guy and put it here in day 9. I'm just copying it. A little bit of stuff which we may have to do it. So I'll just copy this part, put it here. Perfectly fine. And there's just another class where you have to start the story where the class, which is called as thread test, is implementing a double interface, and this guy has got a main method. The main method creates an object of account with the balance of 1000 rupees, meaning here account is a class. Account is a class which takes a parameter of balance. So now once this guy takes it, I have two threads who are parallelly executing. We have to understand here they get executed in asynchronous. So the first guy comes, he says, I want 500 rupees. The second guy says, I want 750 rupees. Let's see how this works. So I have a thread test, which is a constructor here. So the same thing what we have done in the previous example, that's what we are. I will set few variables. This dot A and this dot amount is equal to A. A happens to be account variable, amount is amount. Then I say start. So when I say start, the thread is created and control is given to run method. When you say run method, what happens? It will go to the account class and it will invoke a method which is called as withdraw with the amount which is requested for withdrawing. Now it goes here to withdraw, it just quickly goes. Now what happens? Eventually you have to go and hit to the database. When you want to hit to the database, we have simulated this assuming that it is around 1 millisecond for our understanding. In meantime, there is an opportunity, possibly possible in this case, where the new thread will come and again execute the same one. But as of now, in both the cases, the balance is about 1000. Both will see the balance is 1000. By the end of the transaction, when these two people finish it, the balance would have gone to negative side. On the verge of it, let's see how does it work. So here I click on play. Look at this. This guy receives 500 by A. The balance is 500. Receives 750. But what happened to the balance? The balance has went out to become minus 250, which is wrong. This is one of the problems of having threads. So how do we avoid it? We have to make sure this is synchronized. So what is my synchronized? Synchronized. So this is where the story is. This is where the sorry, not here. I'll just take this. So what happened to this guy? Just a cautious note. Just have a look at this. So this guy just goes, creates a thread. When he creates a thread, it will go and hit a run method. Run method, how much time may this take? This will always run in milliseconds. Once it goes to run, the control is here. This guy invokes a withdraw. Let's assume withdraw will do a balance check. Once after it does a balance check, it will just go ahead and give you the money. But just before this person finishes, now this will take few milliseconds. I'll take for my calculation, I'll say 5 milliseconds. But what is this guy doing here? The withdraw method needs to hit to database. This guy will take 1000 milliseconds, which is equal to 1 second, because they always run slow. In meantime, what happens, since this guy has gone to sleep, this guy will come into the picture and he will also start executing. He will improve run method. So for that, again the control comes. What is the balance here as of now? Because this job is not done. What is the balance as of now? This guy will also see 1000, this guy will also see 1000. And they want to withdraw 500 here minus 750 here. So that is what two jobs getting executed. By end of it, they'll have minus 250, which we don't want to do. How can we achieve this? We have to make this invocation is synchronized. This invocation is synchronized. This meaning when one thread is executing, the other thread should not even have an opportunity for executing it. How do we make it? We can do this in various fashions. You can make you can make a block called as synchronized block with the object which you want to synchronize. So here it is. I want to synchronize an object which is called as A, which happens to be the account. This is perfectly fine. Let's see how does this work. Okay, so the first transaction went on well, but the second transaction, sorry, requested amount 750 is not available and the balance is 500. This is one way of achieving it. Or we know that this method is the one which is or which may be requiring synchronization. For this, prefix this with synchronized. Synchronized. I don't have synchronized here. I click on play. It still does the same job. That's where the beauty of synchronization comes in. So if you see any transaction happening on internet, and there could be a possibility that multiple accounts are being used, in such case, synchronized is a very, very, very effective concept in the market. Create something called as lock. How do you create lock? With something called as synchronization. There are various locks which we can create. So here is a story. We can make synchronized withdraw or synchronized the block of code. One of the two ways. Now, many times, this program I just skipped it. This program, the previous program is the whole idea of this. One of the common problems in the world which we have is the deadlock. The deadlock is a time where one resource is waiting for another resource for executing. So what we do is every time you want to access some resources and you don't want somebody to access it, make sure that you have a method and put every block here in the synchronized. Or it will be much, much, much better if you put it in this fashion. There's a slight difference between the previous and this program. We don't have two adjacent synchronized block. Rather, we have two nested synchronous block. So you have to take a from account and to account. Both has to be locked. Only then do it. Or when you do this, the first account is blocked, then the second account is blocked. If you see that this is nested, so let's not have it with the nested. Let's not have it with the adjacent synchronized block. We should always go with the nested block. So I want to take a control of first account as well as second account. Only then we want to do the transaction. One of the classiest example of most of the money transfer which happens in the world. Thank you for watching. See you in the next video.